No, is it recording? I am. So that has not been saved for posterity. Welcome, everybody. Does anyone have any questions from homework? There were some really good ones in office hours. If no one has questions, I'm going to ask some for you. Okay.
I have a question.
Yes.
For the first section in 1.1, numbers 1 through 5, where it says determine what the key terms refer to in the example for researcher A. I hope it was like the right set of questions that I was supposed to do, but where it says like the population sample, were we just able to state what that means or no?
Oh, all right.
I was a little confused. I wasn't sure and I didn't want to turn it in.
Here we go. I will never ask you a definition question.
Okay.
I hate those. So I didn't assign you any definition question. Don't just tell me a definition. Tell me in this situation, what is the population? In this situation, what is the sample?
Oh, okay.
Yes.
Okay.
Don't just tell me.
I wrote both just in case, but I wanted to make sure.
I'm with you. I understand.
Okay. Thank you.
You're welcome. Something general about homework that I don't think I said until a few people had left yesterday. Part of the homework is in the what's called the practice section. And part of the homework that I assigned to you is in what's called the homework section. I'm really sorry that's confusing. Just some of the practice questions are better than the homework questions and vice versa. So I took from each part. So if you go to the homework and you're like, I got to do 1 through 5, and they start at 40, that's an issue with me, Mr. Waller, then one thing I would say is, we'll go to the page before, but now everybody knows it's in the practice section and what they call the homework section. That's where your assignments are. Is everybody with me? Okay, I appreciate it. It's really hard to do the homework when you're like, I don't even know where the shit is. Like, all right, well, now you do. Anything else, guys, from homework? Oh, go ahead.
You were gonna, I think, talk about the quizzes. Do the quizzes happen during class time or do they happen after?
Thank you. In the last few semesters, I was doing the first quiz online. I'm not going to do that. Quizzes are going to be timed. They will have a due date, like a time that they're due. I normally give you at least 24 hours, if not more, to do it. So the minute you open a quiz, your timer starts. So then you got to turn it in by the time that your time's up. But you have until a certain time to actually sit down and do it. Does everybody understand that? If you have accommodations with ARC, for any kind of disabilities or anything, then definitely get that set up now. And definitely stay in touch with me about how that's going to work. Anything else about anything, really?
I had a question about, I think it was 1.4. The first problem that you had us do was like, I don't know, 80 something. But it was asking you to like describe the study using key terms, but it wasn't like determine what the key terms were. It was just like talk about it.
Oh, 1.4. Okay.
Yeah.
You're all gonna love this. All right. 1.4 introduces several. Can you guys see this? I can't remember. I think I'm sharing, right? Can you guys see the book? 1.4 introduces stuff like explanatory variable. That's the variable that explains something amazing. Response variable. That's the variable that responds to the explanatory variable. It's crazy. You're going to need to read this section. And so the problem Jordan is referencing, it says, here's the situation. identify from the situation things like what the explanatory variable is, what the response variable is. You guys with me? You must use the terminology from section 1.4 to answer that question in the section 1.4 homework. I like it. I don't want to see anything about population or sample. I don't care. I want to see these.
Do you want it in like a paragraphy type thing, or do you want it in like
The
the explanatory variable is this?
The stuff. The explanatory variable is blah. The response variable is blah. The lurking variable is blah. The experimental units are blah. Yeah, yeah. Is that all right? You guys with me?
Sorry, someone threw a dog at me. Can you repeat that?
You know, as happens. You know, sometimes somebody throws a dog at you.
I mean, it's not a lie, so.
What did I just say? So yeah, your answer could just be the explanatory variable is this. The response variable is this, right? In that situation. You with me?
Okay, sure.
So for example, I'll give you one. On the truck driver problem, the explanatory variable is the amount of sleep that the truck driver gets. And then the response variable would be how they react to that amount of sleep. So you guys with me? I can tell you right now, 1.4 is a section that I leave for you to read because I'm evil. I'm a math teacher. I am evil. So you need to read that section and understand what the terminology is. You can ask me questions about it all day long. Anything else from homework? Anybody?
Yeah, I had a question about 17, 1, 2.
Number
Um,
17?
Yeah, number 17.
Okay.
It was, you were talking about like the key terms of population and sample and all of those. And then it asks determine what key term data refers to sample for researcher A. And I was wondering, because I just put the data refers to how many months they lived after the treatment, but
And
do you
that's
want us to like put the population and sample and those key term data?
No. Determine what the key term data refers to. So what does the data refer to in this problem?
So just how many months they lived after they started treatment.
And don't say that because that's the variable. You must say 3 months, 4 months, 11 months. That's the data.
Oh, so you want all of that listed out?
No, you don't have to list it all.
Oh,
You can
okay.
just put 3, 4, 11, and then dot.
Gotcha. All right. Thank you.
You're welcome. I like it. Now, let me ask you, everybody, does no one have a question about these problems? Everybody's cool with these, I guess? These weird ass problems here? Nobody has a problem with these? Okay. These look familiar? Have you guys done these yet? Nobody has a,
These are the qualitative versus quantitative ones?
no. This is the one where you have to identify all of these things.
Oh, yeah, okay.
All right, I'm gonna pretend like somebody said they have a problem with it because somebody does. So, for example, let's look at number 44. So 44 says a cardiologist is interested in the mean recovery period of her patients who have had heart attacks. What is the population that that person is working with? And number 44.
All her patients?
A little more specific.
Patients who have heart attacks.
So look right here. This is what she wants to know about them, but who are they? Yeah, I think you might have just said it. All of her patients who have had heart attacks, right? You might have just said that. I'm sorry if you did. You guys with me so far out there?
Yeah.
It gives you look at this. Is this a lot of information in number 44? No. But you can tease out what the population must be. it must be all of her patients who have had heart attacks, correct? Now, the sample, do you see how it says give examples where appropriate? You can answer the sample question in a couple different ways. Can somebody give me one possibility for what a sample might be here?
Like a group of 40 of her patients who have had heart attacks?
Perfect. Perfect. You could be specific. A group of 40 randomly selected patients of hers who've had heart attacks. What is happening out there? Okay. You guys can Discord, whatever the shit. You can also just say a group of randomly selected patients of hers that have had heart attacks, right? You could give a specific number. You could say a subgroup of her patients. Does that make sense? Are you guys with me? Yes. So guys, notice here, give examples where appropriate, right? And does this problem give me a lot to work with? No. So you can give an example. You can give an example of what a sample could be. I like it. See, didn't you guys have questions about this? Aren't you happy I asked this question for you? Now, the parameter is supposed to describe what?
The population?
So whatever we wrote down for the population better show up in our answer for the parameter. Doesn't that just make sense? So the parameter, what is it that they want to know about the patients? Oh, yes, the mean recovery period. So the parameter would be the mean recovery period of all her patients who have had heart attacks. So parameter and statistic will always be an analysis you do on the data. Once you get the data, what could you do with it? You could take an average, you could do a percentage. All right. I love you guys. Real quick question. So a Discord is just where you guys can communicate to each other over the computer, like you're playing, like you're in a.
It's a chat system, yeah.
Yeah, but it's like you could use you could talk over it, correct?
Yeah, it's like a better gaming version of Skype.
Okay, gotcha. All right. Whatever you have to do to get through, as long as you're paying attention to the class, that's all good. Oh, also, before I forget, I know we're in the middle of a problem, but let me just say this. Last semester, I had in this class, I had students who created a study group, and they met over, and I created a Zoom meeting for them so they could have a bunch of people meet in Zoom and do homework or whatever. And then I would join to see how they were doing if I had time to join. Does that make sense? So if you guys want to create a study group, I can help with that, or you could just do it however the hell you want to. And if you want me to show up and I have time, just let me know how the hell to connect to whatever. Okay.
You can
guys,
also join the Discord, I think, because like it has like a chat room that is always active, and then you can call each other whenever you want. Like
Gotcha.
It's a separate thing, but it's connected at the same time.
All right, because I know anyway. All right. So where we leave off, the statistic. Stay with me, everybody. The parameter was the mean recovery period of all her patients who have had heart attacks. The statistic would be, I think, Melody, was it you who gave me a sample? It was, you said 40 patients, I think?
Yeah.
Right. So the statistic would be the mean recovery period of 40, the 40 selected patients who have had heart attacks. You see how the parameter and the statistic are the same damn thing. They just reference two different groups of people. Are you guys okay out there? No?
Yes, that'll make sense.
Okay. And you never have to, if that's true, great. You never have to say that just to make me feel better. Just let me know if there's follow-up questions. The The variable is related to the question you would ask somebody from the sample. So what would you ask somebody in the sample? In this problem, what would you ask somebody who's in the sample?
What is your recovery period after having a heart attack?
All right. Sure. That's a weird way to put it, but sure. Sorry, I'm picking on your English. So you would say, how long did it take you to recover from a heart attack, right? Or you'd say exactly like you said. Then the variable must be the length of time it takes for a person to recover from the heart attack. Do you guys understand? So the variable is related to the question you would ask. Does everybody understand what's happening? And then the data is answers to the question. So here you have to give examples, right? So you would say something like 8 weeks, 2 months, 4 days, whatever. Right?
So when you do the variable, do you need to add like that little bit that you said at the end too? Or like you say like X equals like so and so?
Oh, I mean, you could say let X equal, that's fine.
Or can you just say like just the question and just leave it at that?
Yeah, you could just say the length of time it takes, yeah. Or you could say let X equal the length of time, that's fine too. Yep. Because it truly is a variable. You could assign a letter to it. Exactly.
But you do have to have like something indicating. So like what she said, just for like the question, basically like the variable, just like the question alone, like when she said, how long was your recovery time? And then after that, do you also have to say like let blank or like the recovery time of like, do you have to put that too along with the variable or just leave the question alone?
So in this case, the variable would be the length of time it takes for a patient to recover from a heart attack. Yeah.
Should just leave it at that?
That's it.
Okay,
Yep.
all right, sorry.
Thank you, Jordan. So again, the homework part of it, so you have to do like 1 through 5 for section 1.1. And that's in the section they call practice. The section they call homework starts at number 40. Yeah. So if you want a number before 40, you probably have to go, pages before that.
Sorry, I had a question. So what's the parameter again and the statistic
You mean in general, or you mean for this problem?
for that problem?
So the parameter would be the mean recovery period for all of her patients who have had heart attacks. Do you see how I talk about the population? Parameter, population. Statistics sample. So the statistic would be the mean recovery period of the 40 selected patients after they had a heart attack. So whatever you say your population is, it better show up in your parameter answer. And whatever you say your sample is, it better show up in your statistic answer.
Okay, that's kind of confusing, but okay.
Okay, so the parameter describes the population. So whatever your population is, it better show up in your parameter answer because that's what a parameter describes. And a statistic describes a sample. So whatever you said your sample is, that better show up in the statistic answer because that's what a statistic describes. Is that all right?
Can I just jump in here to clarify, make sure I got it right? So the statistic is really like a sample version of so statistic is to sample as parameter is to population. And so
it's a beautiful analogy, yes.
in this example, the parameter would be the average length of the mean length of the general population, while the statistic is the mean length of whatever of the sample itself.
Yes, so whatever,
Okay.
yeah. So whatever you said your population was, it's got to show up in the parameter answer. Whatever you said your sample was, it's got to show up in your statistic answer. I like it. So if I said, oh, this thing describes a dog, and then I said, that's a yellow car. It's like, what the hell are you talking? I thought you just said you're going to describe a dog. So parameter describes the population. Statistic describes I feel like I'm confusing you guys more. Maybe I should stop. That's all there is to it. A parameter describes a population. A statistic describes a sample. That's it. That's all there is to it. They are offering tutoring. Yes. Yes. I'm pretty sure I pointed this out to you guys, right? The tutoring.
It should be in the announcements too, if you go back to it.
In the announcements, and it's right here. I think. Yeah, there's some stuff for it, and I think I put it in a module, didn't I? There's 3 places it is. So there's here, MSc Tutoring. So there's that. And I put it in module right there. I like it. So there's a few different options for tutoring for the summer. And of course, you still have my office hours you can come to. All right. Anything else from homework stuff, guys?
Could you go over the population and sample for 46?
Oh, okay. All right. I don't normally do a lot of homework for students, but like we just said with 44, for example, the population was all of her patients who have had heart attacks, right? Because that's what she wants to say something about. In 46, what is the group that the politician wants to say something about?
The voters in his district,
Which voters in his district?
the ones that think he's doing a good job.
No, otherwise he'd always get 100%, which sounds like something a politician would try to do. But who does he want to talk about? That's what he wants to say about them. Who does he want to talk about?
The proportion of voters.
So that's what he wants to, all right, stay with it. What is the group of people he wants to say a proportion that think he's doing a good job? What's the group of people he wants to figure that out for?
Are you talking about the population?
Yes.
Okay, then all?
All
Voters in the district.
voters in his district. There you go. That's the population. Now stay with me. All right, so population is just a group of people or things. The minute you say average or percentage or proportion, that is a parameter or a statistic. That is something you do to data that you get from the group. Is everybody with me? So you have a group you want to say something about, population. You have a group that you can work with, sample. You have a question you ask them, variable. You have answers you get, data. You have a calculation you can make using your data, statistic. And then you have the parameter, which is the thing that you wish you could get, which would describe the entire population. All right.
I have a question about the variable.
Yes.
If you look at question 44, it's talking about the average. And then if you're looking at 46, it's not looking at the average.
Nope, that's right.
To explain the variable, are you still putting like average?
Variable would never have the word
Or no?
average.
Oh,
Never.
okay.
Variable is the question you would ask something in your sample, right? So what would you, and number 46, what would you ask somebody in the sample?
If they think he's doing a good job?
If you think they're doing a good job or not. Exactly. That's your variable. That's it. And then your data would be answers to that question. What are the possible answers to that question?
Yes or no.
Okay, cool. Okay. Now, again, I think I said this earlier. You could actually say your variable is the number of people who think he's doing a good job, in which case your data would be 11, 12, 15, 0, right? So really, you could actually, either way I would accept, because there's are 2 different ways to kind of look at this. Okay. I love you guys. I can see some of your eyes. You're like, what have I done to myself? Some of you guys look like you ate some bad broccoli. I'm sorry. Okay. I'm a math teacher. I'm normal. I'm used to making people feel like that. All right. Anything else? So I have made something live on Canvas. Let me see. If you go to modules, I've got a little something. Where to go? No, Jeff, too far. Here it is, right there. Unit 1, Chapter 1, Practice. This is an actual quiz that I gave several semesters ago. Don't get all excited. This is not the same as your first quiz. This is essentially like a practice quiz. Who is not able to access this at this moment? Is everybody able to access this right now? I think there's at least one person that cannot. What I want you to do. Okay, I'm with you. If you are not able to access on your own, just, can you see it on the screen that I'm sharing? I want you to start. So, all right, I want you to start answering these questions. And oh my God, I'm gonna put you in breakout rooms like 2 days in a row. You're gonna make it. You're gonna make it. I don't do breakout rooms every class. Don't freak out. Oh man, all right. Try to answer these questions. I'll put you in breakout rooms, then I'll bring you back. We'll talk about the answers. We'll take a break, and then we'll finish up chapter 1 and get into chapter 2. Okay. Oh, I got a chat. All right. If you're not able to access it on your own, you're able to see my screen, correct?
Yeah, I just took a screenshot.
Oh, good. There's more to it than this, though.
Okay.
There. Sorry. Screenshot, yeah. So there's 3, 4. Oh. And there's 3, 4. And there's, get down here. 1, 2 again.
Okay, thank you.
You're welcome. All right, guys. So who got 1A? Somebody feel good about 1A?
Random. I got random.
Thought it was stratified.
All right, so
I put
random,
stratified.
stratified.
I put stratified as well.
All right. And why do you say it's stratified?
Because they're in 3 separate groups and then have people picked out of the groups.
There you go. That's exactly what stratified is. So a good sampling method will be random. But your answer can't be random if there's more to it than just names in a box. Katrina, what's up?
Yeah, so I guess as a group, we had a question, or yeah, I think so, I'm pretty sure. It was a collective question, but for stratified, it doesn't, because I noticed that each group, there was a slightly different number. So there was 41 heavy drinkers, 52 light, 48. So for stratified, I know that you take a little bit from each group, but does the number have to be equal, or can it be a different number from each group?
It'd be different. And normally with stratified, you do something called proportional sampling. So say you take from 4 classrooms, but the first classroom has 50 people in it and the second classroom has 8 people in it. So you don't want to take 8 people from each classroom, because then that's 100% representation for classroom 2. Or is everybody sort of with me so far? So you can actually take like 10% from each classroom or something. Does that make sense? So very often the numbers will not be the same. They can either be randomly selected numbers, or they could be a percentage of each group. I like it. Okay. So I definitely agree with stratified. Well, more than that, that's the right answer. Okay. So what about part B? I try to be really specific because I always get somebody who just gives me a definition. Identify the sample and the population in this situation. So somebody else tell me what the sample is.
Ordinal?
Ah, interesting. So I'm not asking you what level of measurement this is at or something. I'm just asking you what the sample is. What is a sample? It's a group, right?
141
41.
randomly selected people in Ecuador.
Oh yeah, sorry, 141. Yeah.
Like 141 selected, randomly selected Ecuadorians. Right? I think that's the correct way to say.
And then population is everyone with stomach cancer.
If that was true, then wouldn't there always be 100% with stomach cancer if you're only picking from people who have stomach cancer?
So would the population just be Ecuador and as a whole?
Oh, Ecuadorians who drink wine.
All people in Ecuador.
All people in Ecuador.
Yeah.
There we go. Because weren't some people that didn't drink wine? Doesn't that make sense to include them if you're doing a study about how wine might affect somebody? Wouldn't you want somebody who never drank wine? That's kind of like a comparison group. Okay, I like it. I like it. So
So
the population,
just real quick question.
yes.
We were discussing that maybe it would be all people of drinking age in Ecuador, because like if you included like children who don't drink yet, that might skew or bias your sample.
Well, there's a few reasons why like age might skew your sample, but to be honest, I have not looked up Ecuadorian legal age of drinking, at least not recently. I have not been to Ecuador.
But you can drink no matter what age you are.
In Ecuador?
Well, I mean, in life.
Yeah.
Well, sure, exactly. This is very true. But the question was about legal age of drinking, which kind of makes sense. But I didn't get that into that many details with this, so that's fine. You could say all Ecuadorians of drinking age, and if there is no drinking age, then you're covered.
And I doubt the researchers are sampling like children in the study, so.
Unless they're really dark.
Well, you could still sample children to get a baseline of what somebody who definitely has never drank before looks like. But anyway, all right, that's getting a little bit in the weeds, but I love it. It's better to get in the weeds than not. Yes.
A quick question about the sample for that one. So like you wrote 141 randomly selected Ecuadorians. I for the sample I split it up. Like I wrote it out 41 heavy drinkers, 52 light drinkers, and 48 who don't. I see that
Yeah, same here.
is a better way to just summarize it, but like would that answer would that have been okay, or should I have grouped it?
It would have been perfect. You're fine. I love it. Just either way you look at it, that's the sample. You can still sample children. Quote of the day. All right. Yes, that is definitely a weird thing to say out of context. Now, is everybody cool so far? Okay. If the researchers find that the percentage in their sample was 3%, is that a statistical parameter? That should be very straightforward.
Statistic.
Totally a statistic, because what does a parameter measure?
The population.
And this is obviously measuring a sample. Now be careful, when I say why, two things. Don't forget to answer the question, because that's normally the heaviest weighted part of the question is the why. Right? And second thing is, I'll often get somebody say it's a statistic because it's a percentage or something. That doesn't make any sense. A parameter can be a percentage too. The only difference between the two is who they describe. And since this is describing a sample, that's why it's a statistic. I love it. Okay. All right. So what about this? This is always a very exciting one. Waiting at the DMV. What level of measurement, not what level of hell is that? That's a whole other discussion. What level of measurement would the number assigned to you while waiting at the DMV be?
I put ordinal.
Ordinal.
I put nominal, but I was thinking about it like Social Security almost.
I see. Get a number at the DMV. Well, this could be a very evil question. Has anyone never been to the DMV?
It's awful.
All right. So you've been. Has anyone never been to the DMV? So I try to be more careful with how I put my questions because maybe somebody's never been there. And if you haven't, I'm jealous. Now, I think most of us have. When you get there, why do they give you a number?
It correlates with what you're there for.
Sure.
In order.
The first letter correlates with what you're there for, but what's the number correlation?
In order.
The order which you can be served.
So I would definitely think the number one answer to this should be ordinal because they're primarily given out to keep you in order. Now, what sucks, if you've been to the DMV and you get H8 and you sit down and they say H7 and you're like, oh, sweet. And then an hour later, they keep saying F6, A216, and you're like, you're never coming back to freaking H. All right, sorry. If you've never been there, you have no idea what I'm talking. You could argue nominal, but that doesn't make sense because the main reason they give out these numbers is to take people in order as they came, right?
I was a little bit confused. I did put nominal because I was a little bit confused because of exactly what you said.
Okay.
Because you get a number, like it's not like super in order because they do call the different sections randomly.
But within each section, they're definitely in order. So it's more ordinal than anything else for sure.
I see now, but it was a little bit confusing.
I'm with you. And that's why I did
Not
it.
random to them. It makes sense to them. It's just not random to them. It's random to you because you feel like you're there forever.
Well, I know I am the next person in the H group, right? It's just, when are they going to come back to my group? I don't know, right? I love you guys. So one big reason why I say to explain why is because there are some situations where I would accept two different answers based on how you looked at it. So do not skip that question there. What about part B?
Just a real quick question on part A.
Yes.
Could you say interval?
All right, I was waiting for somebody to suggest. Well, how do you mean?
Well, so like if I'm H2 and my friend is H8, I'm 6 places ahead of like taking a difference between those numbers makes some kind of sense.
There you go. So I would accept interval if you looked within your H group, you can tell how many people behind you are from being called next in that group. So I would accept interval, although you could argue if it's H8, it's not really numerical, but no, it's fine. I would accept that the way that you've explained it. Does that make sense for everybody? So I really want you to get this. The way you explain it tells me you understand the idea, but you could take this and treat it differently based on what you're looking at. That's why it's okay to be several different possibilities. Okay, so the explanation is huge for these problems. Now, part B, there's really only one answer. Well, who thinks they got the answer for part B? Think about what the actual variable is on
I
part
put
B.
ratio because it's 30% of and 12% of, which
That
would
could-
like division.
I put nominal.
That could lead to like 0% though, right? So I put ratio. So
Yeah, I put ratio as well.
What did they ask people?
What was their hair color?
How could that be ratio? You can't divide blonde by brunette. So don't look at this. This is what I did to the data, right? What was the data? What did I go around writing down on my clipboard? Wasn't I writing down hair colors? Right? And by the way, guys, I love it. I can sense what you're thinking. What a jackass. But I'm not grading you on this, am I? I'm trying to show you this right now so you know what to focus on. Don't focus on the numbers I give you. So level of measurement is all about what the question was, right? Go ahead.
Just said I'll watch out for your sneakiness in the future now.
Yeah, I'm not trying to be sneaky. I am not. I'm really not. It's all about what do you focus on, right? And if you want to look at it as me being sneaky, that's fine. I'm a math teacher. We sort of just inherently do that. I got an A+ in my evil class. So here's the data. So that is definitely nominal. It's just hair colors. What about, now remember what I just said, do not look at the numbers. So what is 3A?
Continuous.
Continuous. Was it necessarily 2 kilograms exactly? I would put all the money I've got, and I'm a teacher, on it not being exactly 2 kilograms. So it's totally continuous because it doesn't skip any values. Weight, holy crap, Jeff. Weight can be measured more and more precisely. It doesn't skip values. All right. Shut up. What do I mean by it doesn't skip values? It doesn't have to go from 1 kilogram to 2. It can go from 1 and then slowly get heavier and heavier to 2. That's what continuous means. You don't skip values as you go from one to another. So what about part B?
Discrete.
Totally discrete. Nobody had 2.3 TV. You wouldn't say that, oh yeah, that TV is, it only exists in this dimension 30% of the time. So it's only 30% of a TV, or it only works 30. No, it's a TV or it ain't. So that's completely discrete. Can only be whole numbers in this case. So I want to be really careful. Discrete does not mean it can only be whole numbers. Discrete means you skip values. So let me ask you this. You ready? What about price of gas as listed at a gas station? Is that discrete or continuous?
Discrete.
Continuous?
But it's as listed would be discrete. Continuous is the price of gas in general, right?
Okay.
Discrete.
Like the theory there. Yeah, that was my.
Because you said it's listed, so it's like what we're looking at right there and then, right?
Exactly. So if you thought it was continuous, then at some gas station, they're going to have it listed as 4.0872946632947767 continued at next station. You know, it's like, holy shit. Don't they go only, how many decimal places do they go out?
Three.
They always sneak that third one in. You ever notice that?
The 9/10 of a penny.
0.089. It's like, what a bunch of jackasses. So they know math well enough in psychology to do that kind of stuff. That's why a couch is always $1,599. That's cheaper than $1,600. Me human go buy. Okay, now, sorry.
For discrete, did you say that it can skip numbers? Like
it has to skip numbers, yeah. So do you guys know that some trucks have what's considered half a door? Do you guys know that? No worries, Katrina. Do you guys know what I'm talking about? Do you guys know that there are cars, are trucks that have what's considered half doors? Have you guys ever? So it's possible for a vehicle to have 2.5 doors. That does not make it continuous because it cannot have 2.7653999762118 doors. It can't, no. Do you guys start to see what I'm saying? So don't say it's got a decimal, so it's continuous. No. So does gas prices at a gas station, but that's still discrete because it skips values. It doesn't take on every value. Is everybody with me? Don't worry, guys. We're almost done with chapter 1, where all this amorphous shit is. We're going to get into chapter 2 where we can sink our teeth into numbers and do some calculations. That'll be nice. You guys will be surprised that you're so happy to see calculations. All right, number 4, the slightly more recent stuff. Here's your options. Who's got 4A? That should be a relatively easy one.
Systematic.
Systematic, automatic. That's right, systematic, because it's every, and my God, I'm writing so perfectly. Jeez. That is so not true. Okay. Now somebody else who haven't I heard from yet, who's not spoken up yet that knows what 4B is. Divide it up, and then you select sum from each subplot. Oh, I got a chat.
Stratified.
Stratify. I love it. Stratify. Sum from each.
Why did my Zoom just close?
Uh-oh.
Okay.
I hate it when you're on Zoom and you're like, oh, they froze, and they're like, oh, everybody froze. I froze. That's me. Okay. All right, guys. Anything from that sheet? This is how I like to do this quiz. Your quiz will not be exactly the same as this, but it will be very similar to this. Okay. All right. So let's take a break, and then we'll finish up chapter 1 and get into chapter 2. What time is it? I'll come back at 2:50. Is that all right? Oh,
Okay.
Summertime. Okay.
You know High School Musical?
So believe
There's
it or
a song. It's like, what time is it? So, okay, don't worry about it.
I get it. It's funny. It's funny.
That's a good one.
Dr. Waller?
Yes.
Can I stay on chat with you just for like 3 minutes to go through a couple definitions?
Sure.
I missed.
Yeah, everybody else are, you know. All right, guys. So the neat thing about section 1.3 is it talks about something that leads right into something else in chapter 2. So what I'm going to do, I'm going to start talking about chapter 2. And then we'll talk about the part that's in section 1.3. So 1.3 has what's called frequency distributions. The tables that you have to kind of count how many data points. So you'll see when we get there, and I'll tell you what's in 1.3. We're going to kind of start talking about section 1, chapter 2. Let's see. Turn off my background. Oh, okay. So here's all the stuff that was here yesterday. Friends off. I have to yell. All my AC on and all that stuff. Yeah. So, chapter 1, chock full of definitions. Chapter 2, we're going to start to actually work with some data, and we're going to do some really kind of basic stuff first. We're going to work our way up. Let's see how this works. Okay. So the first thing we do in chapter 2 is we look at ways to present data that we've collected, right? So the first thing we're going to do is talk about ways to present data we've collected. And then we're going to talk about ways to analyze the data that we've collected. Okay. So what if I collected the ages of people at a bus stop, right? There we go. So I'll say that this is what they came out to be. Not too terrible, Jeff, I guess. So one very quick way to present this data is to create what's called a stem. Well, the book calls it a stem plot. I call it a stem and leaf plot. Stem and leaf plot. Stem and leaf plot is really pretty straightforward, pretty simple. I identify, for the numbers I've got, I identify a stem and then the leaves. And what those are digits. So the stems could be 1, 2, 3, 4. So 1, 2, 3, 4. I like it. And if, for example, I didn't have anybody who was in their 20s, I would still put a 2 here. It would just stay blank. And then the leaves, now tell me if this makes sense. The stem is 1. What are the leaves? 0, 5, 6. Right? And then 9, 9 for 2. And then 0, 2, 4 for 3. And then 1, 5, 9 for 4. So this is sort of a quick representation. It tells me that there's pretty equal spread amongst all the ages. There's not a lot of, there's not more 10-year-old, like people in their teens or people in their 40s. So pretty okay out there. This is not amazing. These are not complete until you do this. Give me a key. So the key here would be 1 line 0 means 10. Now I always get one person who kind of writes that for everything here, but that sort of defeats the purpose. You should just have one example so that I know how to read the whole thing. Okay, so this is nothing amazing. This is nothing crazy. This is pretty straightforward. Now, what if my data, now this is going to be kind of weird for this problem, but too bad. What if my data was actually 1.0, 1.5, 1.6, 2.9, and so forth? Right, so maybe I'm measuring, I don't have a clue. Something about these people at a bus stop, right? Not their ages this time. You guys all with me? This would not change at all. This stays the same, 1, 0, 1, 5, 1, 6. Well, what's going to change?
Key.
Bam. All right, that's the only thing that changes. So the key, the fact that you can make your key differently will help you create your stem and leaves.
I have a question.
Yes.
And it's only, I'm asking this pertaining to the homework because I started it and we have to make the plots too, but do we need to do the key? Is that what you're asking us to do? Yes?
Yeah, you need to.
I haven't done that yet, okay.
Without the key, it's incomplete. Sort of like if you gave me a map, but it didn't have a scale. Right, so the key is sort of like a scale. Without that, it doesn't make as much sense. Melody? Was that you that was talking to me, or do you have another?
Yeah, that was me. Sorry, I'll put it down.
Thank you. Okay. All right. I can erase all this. You guys ready?
I have a question.
Yes.
Can you explain again, where do you get number 10 for the key?
All I do is I didn't have to use this. I pick one of these things and I identify what this means. What does 2 bar 9 mean? Well, now it means 2.9. Does everybody understand? If I just write this once, I know how to read all of this now. What does 4 line 5 mean? 4.5. Does that make sense? This is kind of like the rule. This is the rule for reading this.
Oh, okay, thank you.
So let me make a problem the other way. What if somebody had already created a stem and leaf and it looked like this? What do you got, Jeff? I don't know. let's do this. Sorry, there, okay. And let's say the key is this. Make sure you guys really understand this so well. Okay. All right, so they give me this, they give me that. You should also tell me what this represents, but I don't care about that at the moment. Can somebody tell me what this entry here means?
I'm confused. You put the 0, you put 510?
I totally did. If I tell you
Would it
that
be
5, yes, hold on. If I tell you that 5 line 1 means 510, can you tell me now what 7 line 4 means?
Okay, so
740.
Kick ass, I love it. Good job. Do you guys understand? The key brings it all together. And that kind of kicks ass if all my data values, and this might relate to a problem in the homework for you. I don't know. But if all of my numbers end with a 0, I don't have to write that in this. I can just put it in the freaking key. Yay. It's a little nice. It's not the nicest thing in the world, but I got less shit to write. Sounds good to me. Right? Maybe?
So I have,
Go ahead. Sorry.
go ahead.
Go ahead.
Oh, okay. So I thought the leaf was supposed to be the last digit.
No, definitely. Oh, yeah, I'm sorry. The leaf is what comes after the stem, right? You have a stem,
Okay.
you have leaves that come off it. What exactly do they represent is given to me by the key. Does that make sense?
Yes.
Okay. So watch this. What if I have this exact same thing, but the key says this? Let's say it means 0.0051. So now what does 68 mean?
0.0068.
Exactly, right? Okay. I think you guys get it now. Is that all right? You got some flexibility, you've got some stuff to do. There's not a ton of this in the homework. It's not a crazy big idea, but it's interesting. Now, real quick, if I turn my head this way, doesn't it sort of show me where, I don't even have to do that. I can see that this is the most, but it's interesting that it looks sort of like, have you guys ever heard of a bar graph?
Yeah.
Doesn't it sort of look like a bar graph? If I just kind of outline. So it's kind of nice that way too. Okay. So I can very quickly see which class has the most values. So whatever this represents, most of them were here. Okay. If you had a lot of people coming to a concert, it might be good to know how old, like what age most of them are, right? To kind of tell you what kind of resources you might need at this thing. I don't know. Might be a bad example. Especially nowadays at the moment, sheet stroke and stuff is a real thing. All right. Let me erase all this. So that's stem and leaf plot. Okay. Now, let me think. Am I forgetting something? No, I don't think so. No. Okay, good. We're about to get into the part that relates back to section 1.3. There's a little bit of section 1.3 that bleeds over into 2.2. And I think 2.3, I can't remember. And this has to do with frequency distributions. All right. Okay, now you're gonna have to bear with me. The most exciting part of statistics is collecting and writing down data, which is completely not true. It sucks so bad. So just deal with me. I'm gonna make up some data real quick. Again, right? Here we go. Oh boy, here we go. All right. You can do it, Jeff. I can. I believe in myself. There you go. Look at you doing stuff. Become a 0. There you go. Let me see. Let me do something real quick here. Has everybody got those written down? Okay, so let me show you what sometimes is good to do is to show you where we're about to head. Don't worry about this dude. It's my Loch Ness monster. All right. What we're headed towards, you don't have to create this, just look at this. Just look at this. Is we're going to make something that sort of looks like a bar graph, I guess. This is called a histogram. Let's see. Sure. You can do it, Jeff. Sure, why not? All right. So let's say this is frequency and this is ages. So what was the age group that had the most people in that age group? What is that? Oh, it's you. Oh, it's freaky. I saw that in the corner of my eyes. Like, what the hell is it?
20s.
Say again, sorry?
The 20s had the most? 20s.
All right. So here's the 20s, and they have the most?
Oh, I was from the number data you gave us on the other side. I'm sorry.
This is the frequency. So frequency means how frequently somebody showed up in that class. And these are
Between the 30s and 40s.
Yeah, from in the 30s, right? From 30 to 40. Is that right? Is that right? That was obviously the most. Where were there nobody who was that age?
40s
to 50.
40s to 50s, that's right. So I was here and they killed me. It's some kind of weird Logan's Run thing. They let you live if you're older, but if you're my age, they kill you. All right. Sorry, that was morbid. Too bad. It already happened. So what do we need to be able to do then if we want to create a picture like this from scratch? We need to know, how did they determine that this went from 10 to 20? Why didn't they go from 10 to 18 or from 10 to 25? You guys with me? Can somebody tell me how many classes are there in this picture? Now let me make this a little easier. How many classes are empty? How many classes have nobody in it?
1.
1. How many total classes are there?
5.
5.
I love it. 5. I could have gotten the answer 4 earlier, but now I know I got 5 because one of them is empty. So there's 5 classes, correct? Yes, Jeff. All right. Let me see. How wide is the total range? What's the range? How far does this data range?
50.
Yeah, from 60 down to 10. So that's a range of 50. Is everybody cool with that? 60 minus 10. It's a range of 50 years. Yes? From 10-year-olds to 60-year-olds. Okay, I like it. Nothing amazing yet, right? Now think about it. If I want 5 classes and I have to cover a range of 50, how much should each class cover so that I end up covering 50?
10.
Yeah, does that make physical sense? I've got to cover 50. So how much would each class get if I'm using 5 classes? That is almost the definition of division. I got 50 stuff divided amongst 5 things. Each thing gets 10. I like it. Isn't that cool? No? You're like, I don't even know what the shit that means yet, Jeff. How can I tell if it's cool? So that tells me the width. So how did we get the width? How did we get the width? It doesn't make sense to call this the width of the class. It's the class width. Doesn't that name just make sense? It's how freaking wide the class is. So thank God we just called it class width. I love it. So what is the formula for class width? What did we actually do? What are these things that we just used? Where'd 50 come from? 50 was the what?
The range.
The range, which is high minus low. Jeff, you came and spelled an incorrectly spelled word. All right. And where did 5 come from?
The amount of classes.
Good, the number of classes I want. Do you guys agree with me that if I would have created 6 classes with the same range, wouldn't my width have been different? Does that make sense? So the number of classes I want to use will affect how wide each one is. That only makes physical sense. All right.
You put range instead of high minus low.
I can't. Here we go. All right, good point. Let me put equals range divided by number of classes. I like it. Because the range is high minus low. I like it. Now, let's do that for this shit here. So how do I figure out how wide I want each class? Well, first thing is I've got to know how many classes do you want to use? And here's the rule. Here's like a, it's not really a rule. In general, you want to use from 5 to 10 classes. When do you think you want to use more classes? When do you think you're going to want to use more rectangles?
When there's more data?
There's more data. So how many classes would be good for this?
5.
5. 5 to 10. No less than 5. I like it. There actually is a formula using logarithms, depending on the number of data points you have. We could use that formula if you want to, or we just do 5 to 10, right? So if I have a few more data points than this, I might use 6 classes. Is everybody with me so far? And again, sorry, go ahead. Sorry, no, okay.
Question really quick.
Yes.
How do you determine like the edge cases for on the histogram, like 20, like the number 20, whether you're going to put that associated with 10 to 20 or 20 to 30?
Ah, beautiful. Hold on to that thought.
Okay.
There are 2 ways to do that, and I let you choose which way you want to do. I'll do the textbook method first, the way that this book does it, and then I'll show you the way that I was taught. And you can pick either way. I don't give a shit, right? You're not going to get extra points because you chose my way. Ooh, no. All right. I got dizzy. Hold on. All right. So how do I figure out the class width here? What do I do?
You divide the range by the number of classes.
Good. And what's the range? So we want to use 5 here, we said.
36 minus 17.
Kick ass.
Just 19.
19, I like it.
By 5. We could just round that to 4.
Yeah, so it comes out to be 3.8, and you can round that to 4. In fact, I really want this to make sense. Every class has to be at least 3.8 wide to cover the whole thing. Does what I just said make sense?
Yes.
All the classes together have to cover all this data, correct? So if I make it at least 3.8, it'll do it. So making it 4 will overcover, but that's fine. I just need a place for all the data to go. If I got 3.2 here, why would I not round down to 3?
Because it's closer to 4.
It wouldn't
be
cover-
too small.
3.2?
It wouldn't
3.2.
cover everything.
It wouldn't cover everything. I'd actually have to use more classes. Oh, shit. So you always round up no matter what. Whatever number you get here, but if it's a decimal, you round it up. All right, all right. Is everybody with me so far? I desperately want you to really understand every step we take and why it makes sense. Isn't that silly? All right.
Real quick, how did we get 5 for number of classes for this specific set of numbers?
Because it's a very small set of numbers. So to be honest,
It was just 5 or 10, so we picked 5.
Yeah, 5 to 10. So you could use 5 or 6 or 7. If you use 6 on this, that's fine. For this class, we're almost always going to use 5 or 6, maybe 7, because I'm never going to give you 800 data points, right? Unless you want me to. I am ready.
No, don't do that.
Okay, all right. Okay, all right. So you almost will never use 9 or 10 for a number of classes. You guys with me? Because I'm never going to give you that much data. Okay. Now, I, of course, have a real issue with using board space well. So let me back this up a little bit. All right, let me put this right here. There we go. I need some space for my histogram. Poor little dude. Oh, and then my frequency distribution. So here we go. We're gonna make, oh man, I gotta find, my poor little markers are dying. Poor little dudes. Are you dead? No, you're fine. So now we have our, now this is coming back, I think, Billy. Yeah,
Yes,
this
sir.
question, right? Yeah, this question. I'm gonna start at 17. That's my first data point. How wide is it again? It's 4 wide, correct? Stay with
Right.
me. Now listen. I personally think the textbook method is very confusing. Some people like it better. I will show you a different method in a minute, okay? Oh, good. I'll take that as a good sign. If that's 17, where must the next class start if the width is 4?
21.
21. Does that make sense, everybody? Okay, I'll take that as a yes. Why can't this be 21 also then? Because what'd you say, Billy?
You can't have the same number twice.
Yeah, where the hell? I know there's where would this person go? In both? I double count them? No, I don't. I know 21-year-olds all very happy they can drink, but you don't get to be in both. Sorry. Is everybody with me so far?
Mhm.
Do you understand the issue there? I need a specific place for data points to go. This can't be the same as this. So now I just kind of keep adding 4 down. So this will be 24. Is that cool? Because it's got to be 4 further. Add 4, add 4, add 4, add 4. We get the idea, Jeff. Can you add? No. Don't let them know that. I think they heard you. Oh, shit.
You put 28 to 36 at the bottom.
What did I do?
28 to 36.
That's awesome, Jeff. Oh, that's 29. There you go. I just can't read my own writing. That's my issue. Which one's worse? I can't do math or I can't read. I don't know. Take your pick. So these are the classes. And now we're going to just tally.
Wait, but 33 through 36, that's only 3 numbers.
Yes. Do you notice how they all are?
Okay, sorry.
All right.
My bad.
No, you're fine. You're fine. Stay with me now. I will show you the second method in a minute. I want to get this all the way to the picture, and then I'll show you the second method, and then you'll really see what's going on. So just hold on. In fact, real quick, a little side note. How many numbers are from 17 to 20? 17, 18, 19, 20. Oh, shit.
4.
Sorry. Right? 17, 18, 19, 20. Isn't that 4? All right, sorry. I'm sorry. All frequency is how frequently a data point showed up in here. So how frequently do we see an age in here from the people? How many people go in this class?
2.
3.
3.
5.
4.
I love you guys.
5.
1, 2, 3, 4, 5. Aren't these 3 people 3 different people?
Mm-hmm.
Do they just kind of combine into one weird ass multi-20-year-old person? Blah. No, you don't smush them together. They don't meld together. They're 3 distinct people. So 1, 2, 3, 4, 5. So you definitely count repeats because those are different people. I like it. That would so suck if we're like, no, a 20-year-old already voted, so I'm not going to count your vote.
Wait, so why aren't we listing 7, 9, 0, 0, 0 and then making a key?
I love you guys. All right, now make it, listen, because we are not making a stem and leaf plot. We are making a frequency distribution. Right?
Gotcha.
Okay, I like it. Now, let's keep going. 21 to 24?
2.
2.
So stem and leaf plots are the only thing that we do the key for.
That's right. 25 to 28.
2.
29 to 32.
0.
Nobody. 33, 36.
2.
2. I made a very boring example. It's too bad. I'm a boring guy, so it all works out. Now, I'm going to throw something else on here, and it's called relative frequency. And the name actually makes sense once you see what it is. Relative to the total, how many were in this class? So what's the total number of data points we have? How many total data points are there?
11.
11. How many were in this class? 5 out of 11 total. So all a relative frequency is a percentage. What is 5 divided by 11? Is that 0.454545?
Yeah, 0.454545.
545. Sorry. All right, here we go. So I'll just put 0.45. That's fine. What about 2 divided by 11?
0.18.
1818. I like it. So all these 2 divided by 11.18, 0 divided by 11 is 0, and 2 divided by 11 is 0.18, which we can then make percentages if we wanted to. Is everybody with me? How do you make that into a percentage?
45%.
What's up to 100?
You just got to make it, move it over twice, correct?
Yeah.
Just once, twice, you make it a percentage. Yay. All right. Now we have everything set up to be able to make this picture, Jeff, but for these people. All right. This is not crazy hard. It's just different, right? See, I haven't really given myself much room, but that's too bad. I need this. So let's make a frequency histogram. So you got to really pay attention to what I asked for. If I want a frequency histogram, incredibly enough, you use these numbers. If I want a relative frequency histogram, use these numbers. So if I want a frequency histogram, what kind of scale can I use? I could just use 1, 2, 3, 4, 5. Is that cool? You guys with me? So the scale is going to be huge. One quick way to make a math or science teacher cry is to have a scale like 10, 11, 50, 53, 71. Holy shit. Your scale has got to be consistent. Yes, every step must be the same. Otherwise, you're lying and making people cry. All right. So this is going to be frequency. And now, Billy, I keep thinking of Billy because you had a really good point you made with this whole problem here, right? I cannot do this. Stay with me, guys. Stay with me. I cannot do 1720 because then there's going to be a gap from 20 to 21, and it makes it look like there's more empty classes than there are. How many empty classes are there supposed to be?
1.
1. Should be only one gap in this picture. So we can't do that. So what do we do instead? We do this. You ready? We do this. All right. All right. This is going to be weird. And I don't care because I kind of like this example. There's a limit to me, right? There's a place where Jeff stops. Like here's Jeff, and then Jeff isn't right here. There's no Jeff here, but there's a Jeff here. So there's a limit to me, correct? There's a limit to me. There's also what's called a boundary, right? Personal boundary, you guys, right? If somebody gets really, really in your face, they better be about to kiss you that you know them, or something bad's gonna happen. Say again?
They're gonna get hit in the face.
Something's gonna happen. Something's not right. You step off my grill, all that kind of stuff, right? Get the hell out of my face. So there's a boundary to me, but it's past the limit. Stay with me. Stay with me. There's a limit, physical limit, and then there's a boundary. So these are the limits. These are the class limits And then I go up and down by a half to make the class boundaries. And so all the way down. Notice then, stay with, I told you I was going to show you a different way to do this. If you didn't like this way, I'm going to show you a different way to do it. Don't worry. So now if I do it 16.5 up to 20.5, where does the next boundary start? 20.5. See, there's not going to be a gap. They line right up with each other. Are you guys with me? Of course, I had left myself not enough room to do this.
Then 20.5 is listed twice.
No. That's where the first class ends and then the next class starts right at the same place. Was there any 20.5 in my data?
No.
But you bring up another good point. This method sucks if your data has decimals in it. Then you actually have to go out another decimal place. Holy shit. Stay with me. Stay with me. Stay with me. There's a whole other way to do this. So let me try to give myself some more room for this. 16.5. And notice also how wide is this now? From
4.
16, yeah, 4. So 4 is hidden when you do it this way. 24.5, 28.5, 32.5, 36.5. Okay, I think I got them all. Yeah. So now, how tall is the first bar going to be?
5.
5. And then 2. And then 2. And then empty, and then 2. All right, so this is ages. All right, now, how do you guys feel about that? That's new. Is it difficult? Not really, it's just new. Maybe, do you guys agree with that? This is new, but the math is not hard. Okay, maybe. And some of you guys are like, shut your mouth, dude. Don't assume what's easy. I'm sorry. I'm just trying to tell you, this is not difficult. It's just different. What's another way to do this? Let me show you. I'm sorry, this is all smushed together. I should have got the bigger board here. Another way to do this, and you'll quickly see why some people don't like this way. I like this way. Is to go 17, 21. 21, 25. Some people don't like this because they don't like poor little algebra. All algebra wants to do is help us. Poor little algebra. Is everybody understand what's happening here? This first class is all the numbers that are between 17 and 21. Does it include 21?
Yes, it's because
No.
yeah.
Does it include 21?
No.
Nope. It's less than 21. Is 21 in this next class?
Yes.
Yes, because it's allowed to equal it. So that takes care of the problem. So it's still, you can still see 4 this way, and you can see 4 that way, but I know exactly where 21 goes. It goes here.
You said this is the non-textbook version, or this is the textbook version?
This one is the non-textbook version.
Because I was looking in the module, not the module, but 1.2 for try it 1.10. It does have one example that does the class boundaries are 10 to less than 13, 13 to less than 16,
Oh, okay.
16.
Yeah, they got
That's
some
like familiar.
They do this way much more often than this one.
Well, it seems like there's overlap because it says 17 is less than or equal to X, which is 21.
Which is less than 21.
And then 21 is less than or equal to 20 X, which is 25.
So all numbers that are at least 17 and less than 21 go here. So 21 does not go here, but everything else that's below 21 and at least 17 goes here.
Right? So shouldn't it just be a less than sign, not a less than or equal to?
No, because otherwise where would 17 go? So 17
can
be in the first, but not 21. 21 can be in the second one, but not 25. 25 can be in the third one, but not 29, so forth. All right. So again, like I said, some of you guys are like, well, shit, I don't like either way. Well, too bad. You must pick one of these two ways. Now, the other nice thing about this way is I don't have to deal with limits and boundaries. What would my scale look like if I did it this way? It would be 17, 21, 25, so forth. I don't have to worry about boundaries and limits if I do it this way. There's always a bit of a trade-off. X is less than the next value. Yeah, Katrina, exactly. All right. X can be 17, but it cannot be 21. X can be 21, but it cannot be 25. Exactly. And again, if you don't like this way, because you don't like to be reminded of algebra or inequalities, then you do it this way, and you just have to be careful about boundaries.
You'll take either graph as an answer for the homework problems, right?
Say again, sorry.
Will you take either graphs as the answer?
Yes, totally. Yeah, yeah. You pick a way. Just don't do parts of both ways, right? Pick a way and do it, and I'm fine.
Wouldn't the last one on the new method be 33 is less than or equal to X, which is less than or equal to 36?
Yeah, so this is the one thing. If you have one data point that doesn't fall in, that's where you're allowed to do this.
Okay.
That's a good point. Yes, thank you. Andy.
So when making the table, if you're using the decimal way, you wouldn't actually write the 17 to 20, you would put the 16.5 to 20.5.
Exactly.
And then
you have to.
Okay. And then if you're doing your way, then you're going to make sure you include what's in the red with the algebra signs.
Yeah, so this has to be here, which means then this would be your labels there.
Okay.
Or if you put this here, then this has to be your labels.
Okay, thank you.
I get, so totally do one way or the other. Again, this is different. It isn't difficult. It's just different. Now, let me do one more thing with this. And real quick, of course, histograms, this is not the best set of data. It's a very small set of data, but it will very quickly tell you where things seem to be clustered, how widespread it seems. All right. So creating this visual display of data is a good thing to do. It's a very quick way for somebody to see where your data sort of is. Instead of looking at this, this is better than this. What would happen here if I had to use relative frequencies? So what scale should I use if I had to use percentages, 45%, 18%, so forth? What should my scale then be?
10, 20, 30, 40.
Well, I've got to get up to 45.
Oh.
Yeah, so let's see, 10, 20, 30, 40, 50. Okay, so that'll work. 10, 20, 30, 40, 50. And then, of course, I got to alter these a little bit. But my whole point there is be careful with your scale. Be careful if they ask for frequency or relative frequency. Is that?
Yes, and I actually have a question about that too. Because I was working on it earlier this morning and I was wondering which one are you expecting us to do? Because I did it on frequency. It didn't really ask. The questions didn't really ask.
If it should say create a frequency histogram or a relative frequency histogram. If it just says create a histogram, you can pick.
Okay.
And that's their fault for not being specific. You could pick whichever one seems nicer.
Question.
Yes.
On the graph, you put 28.5 and after?
Say again, sorry.
On the graph, you put 28.5.
Yes.
And then you put 32.5?
Totally, of course.
Oh, okay. And then after 32.5, you put 38.
36.5.
36.
I know you can't read it, but you know exactly that this is 4 apart, correct? We calculated that it was supposed to have a width of 4.
Mm-hmm.
So the minute I know the first one, I know all of them. I just have to add 4, add 4, add 4, add 4.
Okay.
Then I know each one's 4 wide. Yeah.
Okay, thank you.
Like it. So there's actually a decent amount of physicalness to this problem, which is what a lot of math kind of is lacking for some students is you can't physically consider x plus y equals 7. But this has physical considerations. How wide is it? How big is this step? All that kind of stuff. Okay. All right. Let me see. What time we got? Oh.
Roger?
Yes.
For relative frequency, would we do it in percentages or decimals? Doesn't matter. If it was a relative frequency histogram.
To be really honest, it doesn't matter, but
Okay.
Conventionally we use percentages more often, and that's why I made these whole numbers. So I would make that 45%, 18%.
Okay.
I like it. And just to make sure everybody understands, if I did change this, I'd have to change the 45, right? These have to be 18, right? Which would be a little bit lower. You guys understand?
Yeah.
Still has the same basic shape, of course, but it's the scale changed a little bit, so I just changed that. All right, now, last thing, and then we'll call it a day. Let me see, how much do I want to do with that? Well, we'll do a little bit. You ready? All right, bye. Let me ask you, who's heard of percentiles?
Everyone.
Everyone? Why?
Well, it's a pretty general measurement, right?
Well, you're speaking for a lot of people, so let me make sure. Has everybody else heard of percentiles?
Yes, they use it when you take the SAT.
There you go. I was going to ask if somebody's taking the SAT, they talk about it in terms of percentiles. Let me think. Do I want to get into that now? Maybe. Let's do this. Let's do this. Before I get it, let's do something I can do very quickly. Percentile thing is going to take a while to talk about. You should have come into this class knowing how to calculate an average, right? How do you calculate? So if I have a set of data, how would you calculate the average? Somebody just tell me in English.
Add it all out and divide by the amount.
Add them all up. Divided by the number of data points, yes? So math people see this and they say, that's shit. Let's consolidate that. And this is what a formula is. It is a sentence or a few sentences that have been shortened by using symbols, right? What's the official name for add? What's like the technical name for add?
Addition.
So you got product, you got quotient, you got difference, you got sum. I like it. So the sum. So the symbol we use to mean add is the Greek letter S for sum. The Greek letter S looks like this in capital form. Have you guys ever seen that symbol?
Yeah.
Sigma, sigma, sigma. Yeah. So this is the Greek letter sigma, which is basically related to our letter S. This is the capital. Sorry?
Is it sigma pi?
Sigma pi, exactly. Tau, delta, nu, right? All that kind of stuff. So all the Greek letters there for you to create your own fraternity or sorority. Feel free. Now, let me ask you this. If I said, what is this, for example? What's the square root of 9?
3.
3. I love it. What if I said, now do this? What would you say to me? Do this one.
0.
Do you see a 0 in there?
There's nothing.
Not enough information.
So would it make any sense for me to ask you to do this? No. Because it's not taking the square root of anything. This symbol by itself doesn't mean shit. It's the sum of, I don't know. What letter, of course, do we use to represent a bunch of possible values?
X.
X, 11. So X represents all data values. Sum up all the data points. Now, what letter do you think I want to use for the number? The number of data points.
N.
Thank you. I was waiting to see if I had a smart ass. Let's use W for the number of data points. Okay, but no smart ass. Okay. This is the formula for the average, for what we actually officially call the mean. Because math people like 4-letter words to start with M. The symbol for mean, you ready? I don't know. I told you this is going to be huge. This is mu. This is the French cow. This is the letter U with an extra leg. I know it looks like an M. I know some of you guys are going to draw an M. I would love it if you would try to draw a mu. Alpha pi sigma. Okay, awesome.
You drew an M.
I appreciate that. There's a smart ass. I knew there was one out there. Now, this, to be very specific, is a population mean. Population mean uses a Greek letter. So what's a sample mean? It's going to use our letter. Sample mean is called X bar. Formula is exactly the same. It's just if I have a sample, I use this symbol. If I have a population, I use this symbol. So there's our first little tiny official formulas that we're going to use in this class. And let me, yeah, we got a second here. Can somebody please tell me if this is my data, what is the sum of X?
$56.
56.
56, I like it, I like it. And then of course the mean, if this is my population, and yes, I can have a, sorry, yeah, I can have a population this small, it would be the sum of X divided by N, it'd be 56 divided by 4, and that's 14, I like it. Now, stay with me, stay with me. So that's all nice and good. What if I needed to know what this was? Does somebody have a clue as to how I would do this? I will tell you this, it is not 56 squared. It isn't. Why was this so easy to do? What is it asking me to sum up?
Just your total?
The x's. It's asking me to sum up the x's. Do I know what the x's are? Yes, I do. There they are. What is this one asking me to sum up?
The square of the x's.
The x squares. Do I have a list of x squares yet?
No.
No, so let me make a list of x squares. 10 squared is 100, 12 squared is 144, 15 squared is something. Is it 215? I don't remember. 19 squared, who the shit knows? What is that? 400 minus, you could do it, Jeff. 361, is that right?
Yes.
Thank you. Is that right too? Okay.
No, it's 225.
225, damn it. You suck, Jeff. All right, so then, I really want you to understand, we are going to see this symbol a lot. Whenever you see the symbol, if you cover it, you say, oh, I need a bunch of those. All right, that was easy. We have a bunch of x's. And then you get this one, like, oh, shit, I need a bunch of x squares. All right, let me go make them. And then I can add them up. Do you guys understand how that works? Sum up these. If you don't have these, go get them. And then whatever the hell that is, I don't know. 800 and
830.
I was almost there. All right, that's plenty for today. I think I've shoved enough stuff in your brain. This is a nice little introduction to some of the symbols we're going to be using. So we'll get deeper into measures of center. So there are other ways to measure the center of data. The mean is the most classical way to do it. We'll get into measures of spread, which the percentile, measure of position, measure of spread. Anyway, that's going to be the rest of chapter 2, is where we start to analyze data for real instead of just representing it or talking about it. All right, guys, that's plenty. Let me know if you need to hang out. Otherwise, you are free to run away screaming or however you wish to leave.
I have a question for the homework 1.4.
All right, 1.4.
Yeah, for 87.
It's there. There it is. 87. Wait a minute. All right. 87. Oh, yeah, this guy.
Yeah.
So this is what I was talking about earlier.
So the key terms that you want us to do, is it just population, sample, variable, parameter, and statistic?
Definitely not. So you have to go to section 1.4. And for example, explanatory variable, response variable, experimental unit, treatments. There's also lurking variables, confounding variables. Yep. So you need to read section 1.4.
Okay, so we have to do we have to scan and submit the practice and the homework, or just the homework?
The practice scan is to make sure that whatever app or method you're using to scan works on my end. So whatever you use for the practice scan, if I say it's good, if I give you an all clear, then you go ahead and use that same method to turn in your homework. Yeah.
Oh wait, how did you just get to that screen?
Sorry?
How did you just get to that screen?
Oh, this is my special screen.
Okay.
Let me show you what you would see.
I click homework timeline.
No. Here you go, buddy. Homework timeline is where you go to see what the assignments are.
Okay.
Right. So you see what the assignment is, you go do it, and then you click on modules, and you'll see a module that says turn in chapter 1 homework here. See that?
Yeah, it won't let me do the practice scan. It's grayed out.
All right. So you've got to progress through unit 0 straight through. So you've got to click on my video introduction. It would be great if you watched it. If you don't, just hit next. And then you have the introduction canvas. You can just hit next, and then you can do the practice scan. So you got to go through it in order. I'm trying to force you to at least see what's there. Does that make sense?
Okay.
Once you're here, you say start assignment, and then you can upload your scanned assignment.
Okay.
So whatever method you want to use, this is where I can make sure it works on my end. Because there are certain files like iPhone picture files. Canvas hates that shit. So do not use iPhone picture files. They are bullshit. Please don't use them. Yeah. But it does like JPEGs. It does like PDFs. PDFs are probably the safest bet.
Okay. You know, I'm staying at my girl's this month, and then I have a scanner at my spot, but I'm just not at my spot because they're doing they're like redoing all my windows and shit. So
use a mobile scanner. Now.
Oh, use an app on the phone?
No, yeah, it's not an actual like scanner. That would be like difficult.
I'm an old man.
Look here, buddy. On the practice scan, I give a lot of options for Android phones and iPhones. So there's all these kind of, and then there's more beyond this. So you can look at one. Does that make sense?
Gotcha.
Or you could even just take a picture and submit that, and it most likely will work unless it's an iPhone.
Okay.
Yeah, if it's a JPEG thing, it'll work. It should work.
Thank you for your patience.
Sure. I understand. It's all weird. Trust me, I understand. Especially for us old ones.
I actually like this shit. So.
Oh, good. I like it. As long as there's shit out there you like, it's all good. All right. How's everybody else?
Rain Man, motherfucker.
That was interesting.
Maybe this is a dumb question, but what does the cumulative relative frequency do?
I always forget that's in there. It's not.
Yeah.
So all that does, let me see, is this still up here? No. Oh yeah, maybe it is.
The other side.
All it would do is, if I make one more column,
Mhm.
it just accumulates as it goes down. So this would be cumulative relative frequency. So I'll put 45% here.
Okay, so just
18, 63. 63 plus 18 is 81. So you accumulate as you go down. Does that make sense?
okay, so like turn it into a percentage and then just kind of like add it as you go down.
Yeah. So far I got 45%. Now I've got 18 more percent. So now I've got 60 total. Yeah.
And then you're just okay.
The last one should be 100 or close to it. And it might not be exactly 100 if you had to round. Right.
Okay. All right. Thank you.
You're welcome. Everybody else okay? What's going on? So many people still out there, unless they're not really here. How many people are not really here? Go ahead, Anne.
I had a question about the quiz. Is it multiple choice or is it online? I'm just trying to get my head wrapped around it. I'm nervous about the first.
So the way
assessment.
the quiz is going to work, it's actually so all right. You see, there's all right here. Let me do this. Maybe I can. So for us in the modules, so from your perspective, I don't have them active yet. But right after this section, there's going to be another module. Stay with me. And in fact, if I become a teacher again, I can show you. See, there's even midterm stuff, final exam. So right here, the quizzes. So this is not active at the moment, of course, but you'll see quizzes and it will say quiz 1. And you'll go to it. And let me see. I can't show it to you, but you're going to click a button that says start quiz. And then if you want to, you can download it. You don't have to download it. You can just do it. You scan it, you submit it, and you got to do it within the amount of time that I give you. So here I gave 50 minutes for this first quiz. So within 50 minutes after you click that start quiz button, you must submit it. Okay, that's how it's going to work. And then I give you like a deadline of the next day sometime. Yeah.
Okay, perfect. Thank you.
You're welcome.
Okay, man, I'm gonna do both homework assignments now. Thank you.
Okay, sure. And Robert, yes. The only thing that'll be done during class time, I think on one of the videos I said I was going to do the first quiz in class, but I decided not to. The quizzes are all going to be done asynchronously, meaning not together on Zoom, but they're going to be timed and they're going to have a definite deadline. The midterm and the final are going to be done synchronously on Zoom, all cameras on, and you'll have to turn it in by the end of class. Cool.
Are we allowed to go to the bathroom?
No, you must have the camera showing an ankle bracelet that you must attach to. No, I'm joking. Come on. Get up and do whatever the shit. Just as long as you don't cheat, everything's fine.
Cool.
Yeah.
All right, man. Appreciate you.
No worries. Thank you. Everybody else all right? What's up? You guys out there? All
I
right.
had a question about submitting homework corrections.
Yes.
Do we just resubmit it in the same assignment as the homework initially?
Yes. Cool. Thank you. You just turn it right on top of the original assignment. And then it's real easy for me to grade them because I can just go back and forth to see what went wrong and then what went right, hopefully.
Okay. Thank you.
You're welcome. Everybody else okay? What's up? Hello. I'm gonna head out. Bye.